Students and researchers, welcome to this course on deep learning in material science engineering from concepts to applications. Today we are going to start the lecture, that is lecture number 1. Lecture number 1 is always important because we provide you the broad spectrum of the course, how the course will be run, what are the different aspects of the course, and how we are going to take away this forward. So first, let me tell you that this is basically massive open online course, and myself is Professor Krishanu Biswas. I am the instructor from IIT Kanpur. I belong to the Department of Material Science Engineering, and I will be taking you through this course not only by delivering lectures, but also taking your input from different kinds of forums and provide you answers. So this is what myself about it. So my name is Krishanu Biswas. I work in the Department of Materials Engineering. Important aspect is my email address, which you should note down. You can always write me email directly if you have any problems or issues or something like that, so that we can have a direct contact. And that's the last one is my website. So earlier I have developed several NPTEL courses. One important ones are artificial intelligence, machine learning, and material informatics. So what are the objectives of this course? You must have seen the introduction video. So whenever you take some course, you must know what are your takeaway. I mean to say, you spend 30 hours of lectures, listening to lectures, do a lot of assignments, take exams. What are the things you will have it at your disposal? Or rather, what I intend to deliver, so that you are satisfied with your coursework. First, as a part of this course, which is nothing but a deep learning and in material science engineering, we are going to teach you 4 different aspects. We are going to teach you how we can accelerate the simulations. As you know, computer simulation is a very widespread today, and for that we use very expensive ab initio type of calculations like density functional theory or molecular dynamics. And these calculations require huge computational power, some cases supercomputers, and also lot of time. I am not talking about money, that is inherent to this. So can we replace this? It is possible to replace these expensive ab initio calculations using predictive deep learning models. Since you have a lot of data, you can do these deep learning models and replace these kind of calculations. Second important aspect, which is this, map property to structure. How to map property to structure? Material science handles structure, electronic structure, atomic structure, crystal structure, microstructure, macro structures. The 4 different dimensions, right? So macro structures means sample, like this is a pen. It is very long, almost 6 to 7 centimeters or maybe 10 centimeters long, right? Now from that, if you look under microscope, what is you will see is microstructure. You can go down to crystal structure, and further you can go into atoms to electrons. So material property depends on these structures, chemical entity of the structure, physical entity of the structure, bonding nature, electronic structures, how the atoms are arranged in the crystal structure, and many more things which we will talk about later. So we have to know how to map the structure of the properties. This is a classic problem in material science, and it is important that we learn how to connect structure with the properties. Deep learning allows you to do that. It allows you to handle images. We will talk about more in this lecture today. Third important thing is it allows you to handle unstructured data. In machine learning, you cannot handle unstructured data. Here you can handle unstructured data in the sense of atomic point clouds, electron microscopic images, spectroscopic data, and natural language text from literature mining actually. That is possible using this. So, you will be handling a lot of literature. We can extract informations from the literature or data from the literature and do modeling. Fourth one is very important in the sense we all like to design new materials. Why? Because as the demand for better properties is increasing day by day because of the unsatiable need of human. You want to have a very thin mobile phones. How is possible? Obviously by design of new materials. So, using generative models like GAN, what is generative adversarial networks, or there are different diffusion models, we can actually propose new crystal structures and molecules that may satisfy the need of the requirements which are changing every day. These are not all, there are many other objectives. Major objectives of this, if I have to put it together in one sentence, here you are going to learn concepts and also you are going to learn how to apply these concepts. How you are going to do that? So, I will be teaching you mostly concepts with examples. My TAs will teach you how to apply these concepts. So, there will be small modules which will be recorded by the teaching assistants. In the process of my teaching only, they will be joining online and then they will teach you how to develop this kind of applications. Different kinds of deep learning models will show you Python programs and also will show you some of the results which you will get from these machine learning or deep learning models. So, that is will be part of these aspects, so that you get a first hand experience of how to apply deep learning models into real applications. Without that, it becomes only textbook knowledge. You will be learning a lot of new things, but you will not know how to apply it. A lot of students who have taken my earlier courses have mentioned that applications are widely used in real life situations. So, why don't you build in applications? So, we will do that. We will have small snippets by the course teaching assistants and they will give the small snippets as a part of this course. So, that this becomes very intensive. And this is what is the detailed course content. It is obviously very large because this is 30-hour course. So, there will be 60 modules, each modules will be half an hour duration approximately. So, that you can see the videos at your own pace. You do not need to learn at a very fast pace. We will try to structure in such a way that you can study in a very slow space. It will give you opportunities for the students who want to learn faster pace, same time who wants to learn slow space also they can follow it up. So, first is the lecture today where I am going to introduce the deep learning in material science and engineering. Then we directly jump into what is known as the foundations. As you know, deep learning relies on deep neural network. The basic concept of deep learning is neural network. So, we will spend a lot of time on developing these concepts, and as a part of that we will going to talk about perceptrons, multilayers, single layer versus multilayer, different techniques like gradient descents, optimizers and regulations also. Second important aspect of deep learning is what is known as a CNN, convolution neural network. As I told you, we material scientists use a lot of images and these images requires to be handled. CNN is the best deep neural network model which is known as a convolution neural network that allows you to do that. So, here we are going to talk about architectures of these models and different kinds of models which will exist like AlexNet, VGG, ResNet, Google LeNet and Inceptions. At the end we will talk about transfer learning and ensemble models. Modern days deep learning courses is incomplete with explainable AI in vision, right. Explainable AI in vision is what is computer vision is about now. Today we are going to learn deep dives or some kind of techniques like LIME, SAP, occlusions gradient cam, guided back propagation, etc., etc. So, in order to learn that, we also need to know segmentation and object detections, right. Segmentation is very important. If you are handling a deep complex problem, you should know how to segment it properly, and when you segment it, you must know how to detect the objects. That is why there are different techniques which are already available, like UNet, attention unit, YOLO, FASTER, RCNN, and many others, okay, like LSTM, GRU is also there. These are basically hybrids, hybrid deep learning networks. And then you have NLP, LLMs, right, they are connected. I put it together separately because LLMs will also have some part of autoencoders. So, NLP means text processing, right. How can you do natural language processing without knowing the text processing? Embedded things like what to heck, globe, sequence modeling, the different kinds of techniques which you require to handle. Without autoencoders or transformers, you cannot do anything. The chat GPT stands for chat generative pre-trained transformers, right. So, it has built-in transformer into it. So, you learn architectures, self attentions, in context learning, self supervised methods, all these aspects. And lastly, I will introduce the subject called large language models, which are very recent, okay. Reinforced learning for fine tuning, deep generative models like VAEs, GANs, and also some details of the diffusion models. This is in a nutshell is going to be your detailed course content. In this course content, you will be learning not only autoencoders, you will also learn how to build autoencoders, you will also learn some part of how to build a transformer. Similarly, you learn how to build a CNN, okay, as a part of this. So, hence I hope this will be a fun learning with concepts as well as applications, both will be taught to you. What are the books which you will need to follow? There are infinite number of books. That I thought I should show you the font pages of the books. The first book is very good, but it's basically it has a lot of examples. Material Discovery Design by 4 persons edited. Turab is the main person, then Stefan, Frank, and Chris. They have edited these. There are different chapters of this. Second book is written by 3 Indians, Arun Krishnan, Hari Prasad, and Ravindran. This is about machine learning for material discovery. Names are similar, right? Material discovery design, machine learning for material discovery. Here we will talk about numerical recipes and practical applications, very important, you should follow it up. These books are available on Amazon store, you can buy it. And then as a part of this deep learning, you will also know how to accelerate the material discovery. This book is basically edited by Phil de Lima. Please try to Luna, please try to read that. The last book which I already referred in my material informatics course is a new one, T. Jiang's An Introduction to Material Informatics. This has a lot of examples. So, please try to have one of these books, if not all, but we are going to take materials from these books. So, I like to acknowledge the authors of these books to allow us using these materials and teach you in details. So, what is the special emphasis on such a kind of course? Obviously, main emphasis will be design of new materials with improved properties using deep learning tools. That is the basic emphasis. How can you create new materials, design new materials, develop different kinds of concepts in that way. So, that is a special emphasis will follow all throughout this 30 lectures. Well, let me just tell you that why you need to use DL in material science, what are the data and how can you use them in informatics for material design. So, before that let me tell you some important aspects which I have taken from this Google, OpenAI, Meta and others. I acknowledge their websites for that. So, I call it battle of AI titans. How can you compare LLMA, ChatGPT or Gemini? You know, this is the logo for OpenAI, this is the Gemini logo and this is the logo for Meta, right, all of you should know that. and these are the tech giants which are using AI. Well, artificial intelligence is continue to dominate the technological advancements in 2024 onwards, with the groundbreaking developments from tech giants like Google, OpenAI, Meta, and many other companies I will show you. And that requires not only develop these techniques, but also develop chips and computational tools. So Gemini is basically a Google's initial AI model. It's BERT. It was not good. It was launched in sometime in 2022 or 21. It led to a lot of criticism, and then Gemini was launched, and that make a turning point. It has a flash thinking model. What is flash thinking model? It has enhanced reasoning capabilities so that it can understand a problem and deliver. How it does it do? It has a Trillium AI accelerator chip, which is with improved processing capabilities, and it is also going to have Willow quantum chip. Not yet. Once the quantum computing becomes a breakthrough, that also depends on material science, then it will be built in. So flash thinking, whenever you are reading something, sometime your thought process come all of a sudden. That is what is called a flash, all of a sudden. So Google developed this Gemini as a dual encoder system. We will learn about encoders, designed for multi-turn dialogue to understand and generate. It optimizes handling conversation exchange involving multiple turns and diverse topics. So it has a dual encoder architecture. It uses a dual encoder because it has encoders to process the context and response in a conversation. You have seen when you use Gemini in your mobile phones, it not only processes the context, but also provides you immediate response. You could have seen a lot of advertisements of Gemini in the TV and other places, and this is the unique architecture of Gemini that allows you to capture the semantic similarities between the inputs and the output with very clear objectives. It has also memory augmentation mechanisms, incorporates memory augmentation mechanism that can enable you to retain the information across multiple turn of dialogues. When you are talking to Gemini, you are asking many questions. So it must remember that these questions are dialogues and facilitate the coherent and contextually relevant responses. Right? When you are asking a question, you will expect the answer to be contextually relevant. Right? It should not be completely out of order. That is what is called memory augmented mechanism. Third thing, which is a fine grained dialogue state tracking. It is a dialogue based system, right? If you have used Gemini, you will see you want to go somewhere place, you ask that how the place is, what are the different hotels available, how do I reach there. So that means Gemini employs this fine grained dialogue state tracking system to maintain accurate representation of the dialogue context, enabling it to generate responses that are consistent with the evolving conversations dynamics. It is a dynamical system. So it has many good stuff. I am only giving you 3 or 4 important things. Then comes ChatGPT, which has changed the way we think life, right? ChatGPT is another deep learning based model. Okay? GPT stands for generative pre-trained transformers. Chat, obviously what you do chat. It is created by OpenAI, a company which has been created by Microsoft. Sam Altman is the CEO of this company. You must have seen him visiting India. It has powering conversation interactions. A very powerful tool, advanced language based models based on GPT architectures, specifically trained to engage in conversation interactions with users, providing responses that are contextually relevant. Remember these words, contextually relevant. That is the key feature. We human actually, when you chat, we always talk in context. We do not talk out of context, right? Some people do talk, but that is a different story. Majority of us talk in contextually relevant things. How does it do? First important aspect is large scale pre-training. You have to pre-train your model with a large vast of data. That is why deep learning has to be used, right? Machine learning cannot handle huge data, and it allows it to learn from diverse language patterns. Okay, it is one of the best large language models, so that it can understand the nuances present in the human interactions. It has huge database, it can speak you in your own mother tongue also. And again same thing like Gemini, it also have contextual understanding. It excels in understanding the context of the conversations, that is what it says, and this, based on that it generates the responses to you. Third thing which is very unique to ChatGPT is adaptability. It is fine tuned for specific conversations task, so that it can develop customized behavior according to the requirements of your applications. OpenAI also has created O3. It is OpenAI O3 is a generative pre-trained transformer model. Let us not talk about it that. It is a part of Microsoft 365 Copilot AI assistants. It is there in 365, you can use it. It is based on reinforced learning. You will not understand much of this sentence now, but we will teach what is reinforcement learning, how it can be developed, all these aspects. There is another company called Anthropic, okay, which is a European company. It is called AI Research and Product that has put safety into the frontiers. Okay. Anthropic, you must have heard about Anthropic in newspaper. Anthropic is a model called Cloud. Cloud has different versions. Cloud 3.5 Sonnets is one of these. It has autonomous execution with tasks such as typing, browsing, monitoring, and it uses in US presidency elections by Clio tools. Website is cloud.ai, please browse it and see it. Mistral is one such thing. Mistral means it's a powerful cold wind in southern France. So you understand Mistral AI comes from France. It's a French artificial intelligence startup that specializes in open source and commercial large language models. It has different versions like Mistral 7B, Mistral 8x7B, Mistral Large 2, many others, and it has all these qualities what ChatGPT and Gemini has. It has integrated IBM Watson for advanced applications. It has already partnered with Qualcomm to bring generative AI to Snapdragon powered devices. It established a Palo Alto office to attract global AI talents. It is a open weight large language model. So you could have seen all the discussion, LLMs becomes critical part. So you must learn what is LLM as a part of deep learning. Now comes Meta. Everybody uses Facebook, right? So Meta is kind of a revolutionized the whole social networking sites. Its Meta has a model called LLAMA. It's a family of open source large language model, and it came in sometime in April, LLMA 3 and 3.1, 3.2. It has many important. It integrates into Facebook, Instagram and WhatsApp. You type WhatsApp, automatically comes, right? So these are the various tech giants which are coming in and controlling your life, and how they are doing it by using deep learning only. So LLMA is called large language model for assistants. The A words come from assistants. It is developed by again Facebook AI Research, what is known as a FAIR, FAIR. It's another notable conversation AI model. It has all the features like task oriented assistance, it has multi-turn dialogue management systems, and it can integrate with knowledge resources. So that's the key aspects. Anyway, we can keep on talking all these aspects, but you will learn all these things. And in 2026 on device AI integration has been possible by Apple's neural engine, Qualcomm's Snapdragon AI engines, or Google's Tensor chipsets. Okay. You also should know about the other chip manufacturing companies like NVIDIA, AMD, Apple, which are actually supporting the AI powered tools for transcription, streaming and video editing. All these things are basically developed so that deep learning model become all pervasive, all your life it will be there. Recently I came across the Google's GenCast AI. This is open source, anybody can use it and see it. How to probabilistically predict weather forecast. How do you know it's so hot here in Kanpur and going to change the weather soon, right? So the weather prediction is very critical. Our life, mood, everything depends on weather. So this paper, which is taken from Nature, you can look at it. So this talks about how weather forecasting can be done. Weather forecasting is a very difficult task, and can you use AI model to predict the weather? It's very difficult questions. What do you do in traditional weather forecasting? You use equations, big equations, okay, and they are then put into a computational model code. We have inputs from the real monitoring agencies like airports. Every airport has a devices to measure temperatures, measure many things, and then we can use this model to provide outputs. So these algorithms include omissions, approximations, compromises at every step, because you are using equations, right, differential equations. And these equations are sometimes very complex, and weather modeling has to be done in a large area. So your grid is very large, sometimes 10 kilometers, sometimes 5 kilometers long. You cannot predict fine grained weather predictions, and they also require supercomputers. In contrast, GenCast weather model can take the information as input, put into the model, the deep learning model, and give you predicted weather. Okay, that is what it is. So you probably understood something what I told you just now of all these tech giants, but very basic question is, what is deep learning? In a broad sense, you are talking about AI. As you said, AI is going to change your life. Next 20 to 30 years, I may not be there or not here in the world, but you will be here. So what will happen? What is AI? AI is going to be changing the things. AI is nothing but the ability of machines and computers to mimic human mind decision making process, and also problem solving capabilities. This slide's an old one, I have used in lecture also, but this is a very good slide. So it has two important aspects as a part of AI: machine learning and deep learning. Please keep in mind, machine learning is widely taught, it uses structured data. Deep learning uses unstructured data in the form of text, images, videos. So idea is to learn more into these unstructured data things, what is the deep learning, okay. So before you do that, why you need to do this? As you know, we material scientists always like to discover new materials. Why? Because of the demand. You want thin mobile phones, you want very fast aircrafts, you want very comfortable cars. How do you get it? It is the materials which change the whole world. So how materials are discovered? First thing is to use intuition based techniques. You can synthesize materials, test it. If it works, you keep it with you. If it fails, you put it in the dustbin, right? That is very difficult thing, right? You have to do a lot of experimentations, and nobody wants to do that nowadays. Now everybody wants to sit in an air conditioned room, use computers to discover things, right? Who is going to go to the shop floor and do experiments? That is very rare now. So the intuition based discovery materials is slowly phasing out. Next, serendipity. What is known as accidental discovery? If you are lucky, you can discover things accidentally and become a famous person. Glass ceramics is one such discovery. There are many such. I remember it was discovered by Stocky in 1953 after letting a piece of glass in a furnace overnight by mistake. First, you have to do a mistake, then you have to understand you have done a mistake, and then you should understand you have made a discovery out of mistake. These three steps are very connected. Many times we do mistakes, but we fail to realize that mistakes, whatever happened, can lead to a discovery. We just simply throw the things away, knowing that it is a mistake. This is our human tendency. But there are good guys, scientists, who thinks mistakes can happen to anybody, and mistake can lead to discoveries. Best example is this by Sir Alexander Fleming, who discovered penicillin, the first antibiotic, in 1928. Look at what he wrote in Nobel lecture. When I wake up just after dawn on September 28, 1928, I certainly did not plan to revolutionize all medicine by discovered world first antibiotic or bacteria killer, but I suppose that is exactly what I did. This is a picture. You could see all the bacteria are not forming around this object. That is what is secreting the penicillin, and he discovered that. He threw everything out on a September end. It is cold in England, so he threw everything out and then discovered things. That is what it is. There is a paper by R.W. Khan, you should read it. Challenge, response, serendipity in design of materials. It came in an Indian journal called Bulletin of Material Science in 1994. Please read it. Okay? There are many examples. So, you may be lucky to discover that the material. Okay? There is another way of discovering materials, what is known as the Edisonian approach. You know, Sir Thomas Alva Edison, American discoverer, he has tested, he discovered incandescent bulb. He tested this design 3000 times in 2 years, 1878 to 1880. People said he used to lock the doors of the lab and ask his colleagues to work day and night. So, that means it is a trial and error method, trial and error. You try, fail, and sometime will succeed. So, you could have understand nothing can give to good solutions. Okay? So, all these are actually discovery of materials. Next set we will talk about how AI can change the new paradigm, and then we will talk about deep learning in details. Thank you.